This season, as far as scoring power cells, we decided to be a low port scoring robot. Part of our initial strategy was to be able to hold 5 power cells at once, and 5 power cells scored at 1 point per cell versus we estimated we'd be able to hold about 3 power cells if we were scoring up in the high port, just for those added mechanisms and a shipping mechanism. So 3 power cells scored at the high port is worth 6 points, it's 2 points per cell. And so we felt that 1 point difference wasn't worth the added complexity and time spent working on that mechanism. All right. Oh.
Like that.
Has a little contact up top. It could easily traverse in towards the center of our mechanism. To help it along the way, we'll have some 4-inch Omni wheels here, possibly one in here, and then it'll reach eventually our full intake, which will have 4-inch compliant wheels.
Hi guys, welcome to OSU Robot in 3 days. This is a prototype for our intake that we've been working on. This is getting towards the final stages before it actually goes on our robot later today. So we've got a couple mecanum wheels on either side to center the ball into our traction wheels here to pull it actually inside our frame perimeter. So we're going to go ahead and demonstrate it here. And all it requires is very, very light contact with the ball, and actually it's rather low RPM too. Alright. That good? It's about to go in the face.
The question is, whenever it's too fucking low, having that bend is going to mean
all of my beautiful college money.
If I need to haircut it, I'll haircut it, but I didn't know if it was too tall or not. I just guessed.
My God, you cut that out already?
Yeah, it's fast with that and the brake press. That makes a difference. But when you put it down,
So hang on.
I did that jam.
Okay, hey Matt.
okay, we're gonna run it.
So we decided to go with a low port scoring robot. We'll start with the harvesting system. We're using mecanum wheels. One thing that's pretty cool about these wheels is and there will be bumpers here, if we happen to make contact with a power cell on the side, it will auto-center it and pull it into the center. And this was important to us because as part of our strategy, if we wanted to be able to hold 5 power cells at once, we needed to be able to collect them quickly. And so this will intake the balls like that and pull them up into the ramp. We are using nylon tubing because it's grippy and pretty essential in any pulley system. So we have these kind of rollers at the top and bottom of our ramp that have tread on them, and this is similar to tread that comes on those metal framed wheels you can buy. But so once the ball is in this ramp system, like you saw earlier, it just pulls the ball up to the top like this, and then it is blocked by this gate. And so this gate is another part of this mechanism. So once we're ready to score and we have 5 power cells in our robot, the gate will go down like that, and then we will just push them out with this top roller that is identical to the roller at the bottom of our mechanism. So we ran into a couple challenges while making this. The first is that this polycord, sometimes the balls can push their way through it and they can run around on this ramp. So if your team were to do something like this, we would suggest having like a top plate or some kind of guards on the top of this so that those polycord, this nylon does not kind of move back and forth and the balls can't escape here. Another thing that your team could improve upon this design is we went with this just falls down at the beginning of the match, but with defense, someone could hit this, damage it. So another thing we would suggest is making this actuated with pneumatics or motors or something like that, so that you can go in like defense mode where you won't worry about hitting people with that. But overall, this mechanism works well, and we're excited to see how we do in competition. Stop.